Hello there my friends, hope you're all having an awesome day right now. So we have come to the sixth sorting algorithm in this sorting algorithm series, and today we are going to be looking at the heap sort algorithm. So let's get started. So in heap sort we are going to consider our array as a heap, and for that we need to know some important concepts like what is a complete binary tree and what is a heap and so on. So first let us look at what we understand by a complete binary tree. So a binary tree is a data structure which has a number of elements called nodes, and each node can be a parent node or a child node, or it can be both a parent as well as a child node. For example, let me write this array in the form of a complete binary tree. So it looks something like this. So 10, 7, 8, 11, 1, 2, 3, and 4. So this is our complete binary tree right here, and they are connected in this way. So there are different types of binary trees, but for the heap sort, we require to arrange the arrays in the form of a complete binary tree. What do we mean by a complete binary tree? So these elements are arranged sequentially, like the index 0 comes at the top, the element index 1, 2, 3, 4, 5, 6, 7 are arranged sequentially from the left to right. And the reason we are calling this a binary tree is because each node has two children, exactly two children if you observe. 10 is connected to 7 and 8, which are its children, and 10 is the parent. And here 7 and 8 are the children of 10. And similarly, here 8 is a parent node, and 2 and 3 are the children of 8. So in this way, even 7 is a parent node, and 11 and 1 are 7's child nodes. So in the end, we have only 4, and 4 is not a parent node. It is only related to 11, which is the parent node of 4. So this is how the complete binary tree looks. And now let us understand how we can sort the array using the heap sort. And now from now on, I'll be referring to this representation as a heap. So a heap now can be of two types. It can either be a max heap or a min heap. So let's quickly check if this is a max heap or a min heap. So first we look at 10 and we observe that 10 is both greater than 8 and 7, so 10 is proper. But when we come to 7, we observe that 7 is not both greater than 11 and 1, which means this heap right here is not a max heap. And we can also say that this is not a min heap either, because 10 here is greater than 7 and 8, and for min heap, the parent node should always be lesser than both of its children. So this is neither a max heap or a min heap. So since in heap sort we are going to arrange the elements of a list in ascending order, we are only going to be interested in the max heap right now. And you will understand why is this so in a few minutes. So let's now understand how we can create a max heap. So we are going to use a procedure called the Heapify procedure, and this Heapify procedure is going to help us build a max heap. So the Heapify procedure is going to keep the parent nodes always greater than the child nodes. So first it comes and checks this 10, which is the first parent node over here, and sees that 10 is greater than 7 and 8. So it doesn't need to do any work over here. So next it moves on to this one right here, this 7. So is 7 greater than both 11 and 1? It finds that this is not true, and what it does is it swaps the larger element with the smaller one. So 11 will come here and 7 will come here. So now 11 is both greater than 7 and 1. And when it finds that it has made a swap, then it immediately needs to check this element, because there may be a possibility that when this gets swapped, when these two get swapped, then this element becomes lesser than its child. So this is done recursively. So till the very end it keeps on checking. So in this case 7 is greater than 4, so swapping is not required. And then it moves over here where 8 is greater than 2 and 3, so there needs to be no swap. So swapping need not be done over here. So if you observe now, we again come back to 10. So again there needs to be a swap between 11 and 10. So 11 comes here and 10 goes here. So this is a max heap right here. So when we get a max heap, what we are going to do is we are going to swap the first element with the last element. So 11 comes here and 4 comes here. So as you can see now 11, the greatest element in this whole heap, has come to the last position, which means that it is in its sorted position. So now we recursively keep calling the Heapify algorithm. Now there is no need to call the Heapify algorithm for this part since it is already sorted. Since this is already sorted, if we call the Heapify algorithm for this heap, it is enough. So we again build a max heap over here, and we observe that 10 comes here and 4 goes there, and here 7 is the greatest, so 7 will come here and 4 goes there, and here it is already, and 8 is already greater than 2 and 3, and we don't need to swap over there. So again we have built a max heap over here, and all we need to do is we need to swap the first element of the heap with the last element in the heap. So 3 comes here and 10 comes here. So now we observe that the second largest element in this list, which is 10, has come to its correct position. So this part is sorted. Since this part is sorted, now we have to build a max heap only for this heap right here. So we keep on doing this, and in the next step, the next bigger element, which is 8, gets inserted over here, then 7 gets inserted over here, and so on, 4, 3, 2, and 1. So in this way, the heap sort algorithm goes about sorting the elements in the list. So now that we have understood how the heap sort algorithm works, we'll write a pseudocode for this algorithm. Alright then, so now we are ready to write the pseudocode for the heap sort algorithm. So let's get started with the heapify function. So I'm calling this function heapify, and we are going to pass 3 parameters into this function. And these 3 parameters are the array which we are going to pass, then the length of that array, and the variable I, which is used to keep track of the parent nodes. So we saw that the heapify function is going to find the greatest among the parent and its children and put it in the parent node's position. So here this is the parent, and this is the left child, and this is the right child. So we need to keep track of 3 things. One is the largest element's index. So initially it is assigned to I, which is the parent node's index. So initially this is our largest element, and after checking if we find an element greater than the parent, then we'll be putting that element's index into largest. So we also need to know the indices of the left child and the right child. So let me call them L and R. So L will be I into 2 plus 1. So here it's 0, 1 and 2. So 0 into 2 is 0, plus 1 is 1, which is the left child's index. And R will be I into 2 plus 2. So because it's always 1 greater than the left child's index. So now comes the comparison part. We are going to compare these two and these two so as to find the greatest element amongst the 3. So let me remove this. So first, if L is less than N and array of L is greater than array of largest. So why have I included this L is less than N over here? If you see, N is the length of this array, and if at all L is greater than N, then it means that L has gone outside the array scope, and we don't need to perform heapify further. So that is why we have this L is less than N. And if array of L, if the left child is greater than the current largest element, which is the parent, then we need to assign the value of the left index to the largest variable. So the current largest element is at this index. So, and now we need to compare the right child. So if r is less than n and array of r is greater than array of largest, then we need to assign largest with r. And if array of r is greater than array of largest, so if the right child is greater than the current largest element, which may be the left child or the parent node, then we are going to assign the value of largest with r, which is the index of the right child. So after doing these, we have got the largest element among these three. So since we have got the largest element, we can now go about swapping the elements. And here we need to know that if largest not equal to I, only then are we going to swap, because we know that I is the parent node, and if largest and the parent node both are the same element, then there is no point in swapping. So only if this condition is true, we are going to swap. So swap array of largest with the array of I. So the parent element and the largest element, either of the two children, are swapped. We are not done yet. There is another step which needs to be done. And what is that? So let's look at it. And okay, let's consider an example. Let's say we call the Heapify function for these three elements, and we find that 11 needs to be swapped with 7. So 11 goes here and 7 comes here. So what if this 7 was not actually 7, but let's say an element which is less than 4, and that time we observe that the parent is smaller than its child for this part, so we cannot make a max heap. So to deal with such situations, we again recursively call the heapify function. And let us call the heapify function over here. So heapify, the array is going to be the same. N is also going to be the same, the length of the array. And instead of I over here, we are going to pass the largest. And if you look at the reason why, let us say we have just completed swapping 7 and 11 over here, and we need to now call the heapify function for this one. So currently the largest is this one right here, and we need to call the heapify function for this starting from this parent node. So if you recall, largest, which was 11, 11 was found over here, so largest was assigned with this index, which is 3. So from there on, we are going to perform the heapify operation. So that is the reason we are going to include this largest over here. So that completes the heapify algorithm. So next we have to look at the heap sort function. Alright then my friends, so now that we have written the pseudocode for the heapify function, we can now write another function called the heap sort function, which calls the heapify function effectively to sort the list. So let me call this function as heap underscore sort, and let me pass two parameters into this function, which are the list or array that we want to sort and the length of this array, which is n. So first, when we are given an unsorted list, the first thing that we would be doing in heap sort is we are going to be building a max heap. And if you recall, a max heap is a heap in which all the parent nodes are greater than both of its children. So this is currently not a max heap, but an ideal max heap would have 11 over here, and yeah, so that would be an ideal max heap. So in order to build this max heap, we are going to use the for loop. So for I from n by 2 minus 1 to 1. So what is this n by 2 minus 1? So in order for us to build the max heap, we'll need to call the heapify function, and it would be ideal for us to call the heapify function for only those nodes which are parent nodes. So we don't want to call the heapify function for this node, this node, this node, and this node, because they are not parent nodes. So how do we find the relation between the length of the list and the last parent node? So that is given by this relation. So for example, the last parent node here has the index 0, 1, 2, 3. So 3 is the index of 7 and the length of the list is 8. So how do you obtain 3 from 8? That relation is n by 2 minus 1. So 8 by 2 minus 1, which is 4 minus 1, which is 3. So this is the relation which was found between the length of the list and the last parent node's index by the guy who created this algorithm. So, and we are going to go till the first index, which is 0. So this is not 1, but it should be minus 1, because we know that in many languages 0 is the first index of a list, and 2 minus 1 implies that we are going to go till the element which comes before minus 1, which is 0. So yeah, so in this range we are going to call the heapify function. So heapify array is the same, and we need to pass the length of this array, and that is going to be n, of course, and I will be the index of the current parent node. So that's it. After this completes its execution, we'll have a max heap in place. So after we got our max heap, what we're going to do is, let me just show you how the heap will look after this statement. So 11 is going to go here and 10 shall be here. So we have got a max heap right here. And after we got a max heap, what we are going to do is, we are going to swap the last element and the first element. So 4 will come here and 11 will come here. So we are going to essentially swap the last and the first element. So swap array of n minus 1 and array of 0. And this swap statement right here is sufficient only for swapping these two and getting the heap. But how do you sort these elements? So for that, it is not enough if we just write for the last one. We have to consider all those elements. So we are again going to use a for loop. So for I from n minus 1, which is the index of the last element, to 0. So we are iterating from this element to this element, not the first one, because if we reach the first element, then we'll have to again swap that element with itself, which is not required. So this is our condition for executing the for loop. So, and we also need to change the indices of these. So array of I and array of 0. So yeah, that doesn't change because the first element is always the first element. So after swapping, we are again going to call the heapify function, because we need to sort all these elements right here, because this is already in its correct position and we do not need to heapify this part. So for calling this, we'll write heapify, and array is the list that we are going to pass. N is the length of the array, and this time it's going to be I. And this time, for a change, let us build a max heap from the first index. So let me write 0. So why have I included I over here and not n? So the reason is I is going to vary from n minus 1 to 0. So the first time I is which is n minus 1, and that is the length of this part. So if you see, when I points to 8 minus 1, which is 7, then I gives the length of this part. So similarly, when I points here, it will give the length of this list and this part and so on. So that is why we have got I here, because it keeps getting decremented by 1 each time until it reaches the top. So this heap sort function keeps calling this heapify algorithm, and each time this heapify gets executed, and this 4 and 10 are now interchanged. Then here 7 and 4 need to get interchanged, and 4 comes here, 7 comes here, 8 is proper. So again we have this part is a max heap right now. So So we swap the first element with the last element. So 10 and 3 are swap. So 10 has come in its correct position. And we are going to heapify this list right here. So 8 comes here, 3 comes here. And now this list has become a max heap. So we can swap 2 and 8. So 8, which is the next largest element after 11 and 10, has come in its correct position. We need to heapify this part right now. So 2 and 7 are swapped. Next, 4 and 2 are swapped. So this heap has now become a max heap, and we can now swap 7 and 1. They are at their correct positions. Now for this part right here, we are going to make a max heap out of it. So 4 and 1, they get swapped, and 2 and 1 are again going to be swapped. So we have a max heap. So this one right here is a max heap, and we can swap the first and the last element, which are 4 and 1 respectively. And this one, we are going to make it as a max heap. So 3 and 1, they are swapped. So again, this has become a max heap, and we are going to swap 3 and 1 again. So 1 and 3. So on it, the heapify function is done for this, and 2 and 1 are swapped, and back they are swapped again, so their positions do not change. And this is the sorted list, guys. So the sorted list is 1, 2, 3, 4, 7, 8, 10, and 11. So we have got the sorted list by using the heap sort function and the heapify algorithm. And this is a very good sorting algorithm. It is used in many applications because it is really fast. So that's it about the heap sort algorithm, guys. Make sure that you subscribe to my channel and watch all my videos till the end, and we'll see how we can implement this heap sort in Python in the next video. So bye for now, and see you in the next video.